more and more challenging for educators to develop courses that meet the needs of industry, given that industry has so many different pathways, right? So with stem cell, you're going to go stem cells, you're going to do more cell work, you're going to do more biomanufacturing type work, you're going to do more testing. So what can an educator that's not been spending 20 years in the field, how do they go about doing that if they don't know how to start? So obviously we want industry to be involved here, to recognize what students know. Again, that depends on your specific company, how much they want to get involved in the actual competencies. One of the things that we haven't really gotten into, which I think is the next step, is to facilitate the process to award credit for prior learning, because as you'll see, a lot of these competencies that are core are not unique to bio at all. So, as I mentioned before, the reason to focus on core, there have been all these other efforts about skill standards in 1994, and those are documented in the booklet. There's a timeline, 1994, 1995, EDC was involved, agriculture, bioscience skill standards, then the competency model, biomanufacturing, the Northeast Biomanufacturing Center has done their skill standards, BioLink has skill standards, the Washington State skill standards, which are divided into R&D and clinical and a bunch of other stuff. But all those skill standards have really tried to be comprehensive, to like document the core competencies that the technician, all the competencies that a technician would need to know. And they become cumbersome and they become just so incredibly big. So with the growth and maturation of the industry where you have so many different sectors, let's give the teachers and students something to focus on that's just central to everything. And so that was another motivating factor. All the diverse jobs, you're not really talking about a job when you talk about comprehensive skill standards, because the jobs are usually much more discrete. So the process that we took was to do a preliminary identification, and this is where my working group comes in, and I have a slide on that, by the Skill Standards Working Group. And then was to review by other bioscience educators, and that was a pretty exhaustive process. I mean, we talked about this for quite a while with our educator communities in BioLink and NBC2. And then get an industry review, and then to revise the critical work functions and key activities. Now, those words I haven't really introduced yet, so I'll talk about that. And then to keep refining, and this is still ongoing, by the way, this identification of, this is going to die. These freebies from meetings, they die. The continuing identification of assessments and performance indicators is sort of an ongoing process. So, as I mentioned before, once medical device got their list of skill standards, we now had 3 lists. So we had a list for biomanufacturing, we had a list for medical devices, and we had a list for bioscience lab skills. So my idea was, let's just start with the smallest list and start matching and see what matches up. And the biomanufacturing, because you may be able to see that, it's a much more proscribed list. It's a much more defined industry sector than bioscience lab skills, hoo-ha, lots of diversity there, and medical devices also very huge. So we started with that biomanufacturing list, and then we started matching. And I need to say a little bit about the working group representing the 3 industry sector hubs. The team members, Vivian on Winward from medical devices, although she also has a huge amount of experience in biomanufacturing. All 3 of us had industry experience in very different sectors of the industry. Linda Rafus from NBC2 in biomanufacturing, worked in biomanufacturing, pharmaceutical industry. Myself, primarily R&D, 2 different startup type small companies, but I've been working around other. In fact, one of the startups that I worked for years ago was trying to institute a quality system. So I saw that disconnect from research and development to the quality system world. So that helped me a lot in talking about this. So you don't have to look at the details here. Some things about the process were easy, right? Notice the line up across the way. Oh yeah, that's gonna work. All we need to do with things that line up really well is come up with common language. That's challenging, but not such a, not such a big deal. Other things, not so much, okay? Not so easy to align. So that was kind of what we spent our time on, the core skills group. Spent a lot of time figuring out, what kind of language would work for all three of these groups. And that, in many ways, was challenging, particularly with regard to medical device. So when I think medical device, I think diagnostics, because it's covered in the same area of the FDA, right? So, and it's still wet lab, so you still have, pipetting, and you still have solution making. But every time we came back with competencies that dealt with liquid handling, medical device said, no, we don't do that, because they were thinking imaging equipment, catheters, and things that are electronic, right? So that was a challenging thing, to word the skill standards so that they would be encompassing of all those three sectors. And then it came to format. How are we, we were dealing with lists of skills, lists of activities. How do we make the format the most useful for people? And I come back to the second part of what a skill standard is, and it's how do we know when workers are performing well? And in order to do that, we need to have a little bit more than just a list. So this is actually not unique to us. This was the format for the Washington State skill standards. And a lot of us really liked this particular format. And it's organized in terms of the big buckets, which are critical work functions. And then inside the big buckets are these key activities, which are essential tasks. Big bucket example, meaning provide routine facility support. You can see that's huge. Essential task would be maintain inventory of raw materials, parts, components, and equipment. Then you need a performance indicator, which is some concrete, visible way that we know the individual is actually able to do this. And that's where the rubber meets the road, right? Because then you have to really get specific about how you're going to measure this. And then the assessment is the actual exercise to determine proficiency. A lot of these competencies are formulated in terms of a fairly complex activity. And so underneath that activity, you have to know some specific other things. To do a standard curve, to get a protein assay, underneath that all is pipetting, and knowledge of measurement, metrology. There's a whole list of things you have to know and can be assessed on before you get to that activity level. So we're really looking, at a higher level of assessment here. This is just another way of looking at the format. Some people like a more visual look at general area of responsibility for the critical work functions, and then all the other things underneath it. So what did we come up with? What were the big buckets? Okay. Now you can probably make some guesses here. Most people can. Maintain a safe and productive work environment, provide routine facility support, perform measurements, test assays. This is a biggie: comply with applicable regulations and standards, manage and communicate information, and perform mathematical manipulations. You can see they're very, very general, very big. But other than performing measurements, tests, and assays, and even that you could argue, there's not something that's really specific to the bio world there. Okay, it's very much about working in a regulated industry. So when you can look in the booklet to show the final, well, it's not even final, but the complete core skill standards as of now. We're always adding things like the assessments. There's a few suggested assessments in here. The way that we drew this up was, again, as I went back to the point I made earlier about trying to be general. There's another couple of examples, but it's easier to read them in the booklet than it is here. Is that we tried to draw it so that even though the critical work function and the key activity had to be in general language to basically satisfy everybody on our hubs, in our different hubs, the assessment can be very specific to the industries that you're serving and the companies that you're serving. So when you get down to the level of performance indicator and assessment, you can make it so that it targets the things that your students do in your area and just satisfy your companies or your advisory committee. That's what I just said. Philosophy of harmonization. Also, there's a philosophy of core here. We're not trying to say that every entry-level technician does all of these things. Okay, that's not what we're saying. So, but what we are saying is that these core skills are things that an entry-level technician should know and be familiar with, and hopefully have learned in their program of study. Even if they didn't master, I don't like to use the word master, but at least they have learned about these things. So they're not going to be completely blindsided by quality regulations and standards, for example. And that's where I've gotten some pushback, okay, from some of the R&D people. Not a lot of them, but some of them are like, well, this is for people that work in big companies. This is not for my students, right? My students go to R&D companies and they work in the research area and they don't have to worry about that. Well, having that experience myself, I can argue pretty effectively that yes, they do need that kind of exposure, even if they're not being held to that. They need to be questioning, well, who calibrated these pipettes lately, right? They need to have some idea of traceability and stuff like that. So come on in, have donuts, coffee, don't mind me, I'm just gonna talk.
This is Dwayne Davis. Jeanette, he sets up the coffee. So.
Oh, good.
He's our chair of fiscal science.
Then I don't have to invite him in. So a little more about the industry recognition process. I kind of jumped the gun by saying I got some pushback already. So underlying the whole process were the people on this grant, most of them in the industry sector hubs, had some industry experience. My team, myself, Linda, and Vivian, have quite a bit of industry experience. And in addition to that, we've been working in programs, myself for 20 years, that have industry advisory boards, and I've been internship coordinator for most of those 20 years. So internship coordinator, in fact, trumps a lot of other experiences, because you go out to, in my world in Madison College, when you're an internship coordinator, you do 2 visits while the student is interning. You do once at the beginning. You get load for it. You don't just do this on your spare time. You actually get 30% load, as much as a program director. I think it's cut to 25 now, but in the way of the cuts. But you go out and then you talk to them at the end, and you could do an exit interview with the student at the industry place, at the company. And the company tells you, first in front of the student and then alone, what the pitfalls were, if there's some problems with the student and their lack of knowledge or whatever. So that feedback to me has been huge over the years, and I've often come back and said, they're really happy with this and they're not really happy about that. So, and we've tweaked things. Most of the time though, the thing that they say that's so positive about our students is that they're comfortable in a laboratory environment. And then they'll go on and make more specific comments. And if they've ever had a complaint, other than, there have been a few complaints about the quality stuff, but mostly we've fixed all that, in terms of a quality system and knowing about GMP. But it's been about computer skills, which I've always found funny, given that usually the student population is younger than I think would have problems with computers. But it's because they're very good at probably certain aspects of computer use, social media, et cetera. But when it comes to really taking on a piece of software that they haven't already been familiar with and really tackling it, that they're scared of it. So and that's why when I got ready to do these skill standards, I was really focused on making sure that got in there. Anyway, I got off target for a minute talking about internship, but industry recognition process was the makeup of the committee. Preliminary review was done by 2 subject matter experts to help develop an online survey, which would go out to many other industry people. And then the broader survey was an online survey that was up for about 2 years, asking, maybe a year and a half, to ask industry people whether these skills were appropriate. And really, we had pretty universal agreement across the country about the skills, with the exception of that pushback I mentioned from a couple of people that were in startup companies saying, my people don't really need to know about all that quality stuff, or the regulatory part. But they still had like 95% agreement with what we had there. So that was good to hear. So we had face-to-face meetings with our National Advisory Council. I didn't mention that for the grant, for the C3BC Consortium grant, to get feedback on it, and then the online survey. And the online survey specifically asked if you supervised entry-level technicians, and if you didn't, you didn't take the survey. So that was important for us too, because I didn't want to really hear what the CEO had to say. You know, no offense. I mean, I do, but for this particular survey, I wanted to hear people who actually supervised. So how are they being used now? Russ was telling me there's a local example that they're using them for Herbalife to do their incumbent worker training, or to do,
Yes.
yeah. So that's one of their ways, and there's several examples of that in the biomanufacturing sector where they're doing incumbent worker training with that. Back to my shtick on all this is that I want educators to look at them and make sure that they're addressing them in their programs. So that if we did nothing else, even if we changed nothing and made no new credentials, which we're doing new credentials, people are making career pathways out of this, because it's really easy as an educator and somebody that's really excited about all the new and groovy things in biotechnology to go, let's go do stem cells, let's go do CRISPR-Cas9, let's do qPCR and do research projects, and then forget about the things that are actually going to get their students hired and promoted in a company. So we can still do all those cool things, but we need to stay focused on what are the core essentials. People are using them for assessment purposes, for completion of courses, for completion of programs of study. I think everything is pretty much up there. This is an example from a colleague in Austin Community College, and she put this together for one of our grant meetings of how she's using the skill standards to put together an entry-level certificate, which will then be a pathway into several other avenues, for associate degree, for biomanufacturing certificates, and for regulatory affairs. And she keeps going with this. And she's working a lot with her high schools to actually have dual credit options that also feed into this pathway. And that's something that we can also focus on in the future too, if you're working with your high school. Implementing them, there's ways to align them with state and local standards, focus on area needs, and use them to develop even more standards. Now this is my caveat for the person or persons who says, but there's no liquid handling in there. We're saying they're necessary. We're not saying they're sufficient. Okay, you still have to put the skills in there that are important for your industry in your area. They have to be there. And I would say most of us are going to have liquid handling. I mean, you're going to have solution making in some form or fashion. And the way it's written in the skill standards is in terms of doing the calculations that are important for your work area. So if you look in there, you'll see examples that relate directly to things like solution making. What else? I was just telling Russ that I went to a couple of meetings recently. There's the National Career Pathways Network, which is working primarily, there's a lot of two-year people that went to this conference, and the conference has been going on for quite a while. Has anybody ever been to that conference, Career Pathways? I probably won't go again. I went because of the skill standards and with my colleague in Austin Community College who's working directly with high schools. But there is a big move afoot amongst high schools to do career pathways. It's even in Madison. And a lot of push for external certification to validate those career pathways in the high schools, coming from Perkins Grant stuff. And I don't, that's as much as I know about it. So there's some new Perkins Grant regulations evidently that have to do with needing external certification. And so skill standards could be used as part of that. There's not a certification yet specific to these skill standards, but there are some that incorporate these. So they weren't developed with us, but they're still very similar to what we've got. We're going to continue to work on these assessments because doing an authentic assessment, doing something that really closely imitates what a student would do in the workplace, is really hard to design in a teaching laboratory, but it's so important. It's really important to design that. And the other conference I went to was the National Science Foundation conference in DC recently, and one of our colleagues at Salt Lake Community College is doing competency-based education. Now that's a buzzword, right? Competency-based education, and we all do that to a certain extent. And we're teaching people competencies. We're not teaching them just to read a book and then take tests. But what she means by that is really an open entry, open exit type of program. Sort of what Mike Lairs is trying to do with the lab, but on a larger scale where a student can move at their own pace and do a competency and then come back and do another competency, and it might take them 3 weeks to do something, it might take another student 16 weeks to do something. It's a very challenging model to implement in terms of teacher loads and labs hours and all that kind of stuff. And there's various ways of doing that, various baby step ways of doing that, but these kind of skill standards could definitely be used in that kind of a competency-based model. You know, it seems like the shorter you make the module, you know, in terms of students' ability to sign on to it, say I can commit for 4 weeks or I can commit for 8 weeks, you get better enrollment and stuff than you do if you have a full 16-week semester. It's a hard one to staff, but it may be the way that we're going. Work-based learning was also a big topic at the couple of the conferences I went to, and these kind of skill standards can be used to evaluate that. And then back to assessment of prior learning. Like I said, there's not a lot of biospecific stuff there. At least when you draw it generally, it doesn't read, oh my gosh, this must be a biotechnology program. You have to like dig into the specific examples before you get to that specificity. The booklet has a lot of places, and you've got one, so I don't need to tell you what the booklet is. So now I can answer your questions, or you can tell me stuff that's interesting about North Carolina.
Oh, wow.
Maybe there's something for you.
Actually.
Yeah. Yeah, we've heard the dog stories, now we can move on.
Yeah.
What?
Sure.
That's something that I've heard a lot. Is there any data there to support that it works and the students are retained and they are employed?
In biotechnology, no, there's no data. This session that I went to at the National Science Foundation ATE meeting, my biotech colleague was the one talking about implementation challenges. She's the only one I know, Salt Lake is the only one I know that's trying to do this on this scale, the open entry, open exit. I mean, a lot of us are assessing competencies in classes. That's not particularly, I mean, it's still challenging, but it's not particularly new and innovative. But in her case, but other fields, other industries are doing it. We had several people in the room that were doing it for manufacturing, they were doing it for automotive. The advantage they have is that they have a lot of already existing industry certifications. So they have stuff they can either bring in or, you know, test out. It's already codified, right? And every time I would say something, I'd go, but there is no such thing in biotechnology. So I was trying to point out that she's really, my colleague is really leading the way. And Russ knows her, Jean from Salt Lake is working on that. So yeah, I think the students would love it. It has a few other challenges other than just teacher loads. You know, what about the cohort idea? You know, a student has a group of students they work with and they go through the program with, and you know, that really kind of falls away if you are on your own path and you're doing asynchronous learning. But probably some variation of that is good, you know. I think even making just 8-week classes would help a lot. I mean, I know from my own personal experience with taking classes like Spanish or piano or whatever, when it's a full 16 weeks, I go, well, I really have this trip planned and that trip planned. I'm not sure I can commit for 16 weeks.
It's still that way.
Yeah. You know, and for me, I have different challenges of commitment. not what a 22-year-old who's trying to work and support their 2 children. I mean, those are different challenges. Thank goodness I don't have those anymore. But that's still something that makes it hard for them to commit. They don't know what their work schedule is that far out, et cetera, et cetera. So, but I'm not gonna lead that charge at my school. I'm gonna let somebody else do that. Any other comments or questions about the skill standards or anything else we've talked about? All right.
Do you have a list of the biotechnology skill standards anywhere where I can probably go and look at what you guys
All.
have? All the compilations of all the lists.
Okay, all of the ones that the core is all here.
The core is here.
Core is all here, but all the existing ones, yeah, those are on the BioLink site. There's a link that's listed in here. I'll see if I can find it for you. Yeah, on page 17 of the booklet where it says industry subsector skill standards and past skill standards.
Okay, thank you.
Yeah, that link, it's long.
Thank you.
If you go to the BioLink site and type in all of that, you'll be good.
Okay.
Yeah, and that's a whole, there are links to all the previous ones, and there's linked to the current lab skills one and the current biomanufacturing one. Then the Northeast Biomanufacturing site is probably the best place to go for those. They're linked from here,
Okay.
but NBC2?
I've heard of it.
If you type NBC2, it's not the first thing that comes up. The first thing that comes up the TV channel, but the second thing would be Northeast Biomanufacturing. I
Okay.
think it's northeastbiomanufacturing.org or something like that. And then from Russ's site, from biotechworkforce.org,
You
it
can
probably.
actually, if you go in there, you can actually pull up the skill standards in a flip phone,
Okay.
and all the links are activated. So it'll take you back to BioLink. It'll take you back to.
Oh, there you go.
NBC2.
That's the way to do it. Then you can link back.
And of course, the very expensive but very good virtual medium, skillscommons.org. You can get them there too.
Okay.
People are trying to figure out what to do with skillscommons.
Yeah, people are trying to figure out what to do with skills
But it's there.
Everything is there. That's one of my problems with the BioLink site, actually, is everything is there, but it's very hard to find. That's why we put the specific links in there, because there's so much there that the webmasters had to bury things, and then she keeps adding on, and so then it gets harder and harder to find the previous thing. So, but yeah, but you can always email me if you need, or Russ can help you too. But
So when you were at the PI meeting last week, aside from our usual collective group, I mean, did you hear anybody talking, or has anybody sort of said, has anybody come to you and said, Jeanette, these are really cool. I think I'm going to try to go back and change my curriculum, or incorporate them into my curriculum, or do you think that that's already kind of like a done deal?
I think people have been aware of them in our group for such a long time now that they've already done. I mean, the person that talks to me the most about this is Linnea, because she's been working with the high schools. But yeah, I think the people that are going to be worked with them have already kind of. It's fun to talk about resources for teaching them, though. We have another grant that with Pellet Productions, which is the company that does ATE TV, to do an interactive movie to teach quality and regulatory. And that movie is up now. And I don't know, in the media world they call it a choose your own adventure. So what's filmed, and it was filmed with real actors. It was quite an elaborate production, which I was able to go and be the educator on site. And it was filmed in Worcester Polytechnic, their biomanufacturing training center in Massachusetts. And what it has is it has these characters, which one of them is a manufacturing technician, one of them is a supervisor, one of them is a quality control person. They have these dilemmas that they face in their work about what the right thing to do is. Documentation, should we, just start over with a new batch record? No. Should we just scribble out the bad words and put in the good words? No. And then it has, but you can click and see what the consequences are of your choices, whether it's a good choice or a bad choice. And they have several different dilemmas, and that is the website for that is Franklin Biologics, either .org or .com both work. And we're still developing supplemental materials to help that out. Actually, yeah, I should have put that up. Franklin Biologics, like Rosalind, it's named for Rosalind Franklin. Believe it or not, Franklin Biologics was not taken. The domain name was not taken, so we were able to get .org and .com. So yeah, it's really good because there were real actors, and so it doesn't look like a hokey kind of production. It looks really professionally done. So that, for teaching quality and regulatory in a instructional lab, it's challenging, right? You know, you just don't have the same feel as working in a company. I mean, it's like, oh yeah, it didn't work. I'm just going to repeat it. You know, can't do that. You can't do retesting. So if you're doing quality control for a company, so you know, those kind of dilemmas are portrayed in the movie in a way to try to make it real for a student before they actually walk through the doors of the company. I know that's one of the challenges. I mean, how many times can you go over good manufacturing practices in ISO 9000? I mean, it's deadly boring, and it's not real, and it's not, you know, alive to the student. So you need a way to make it